In this experiment, the wetted surface area in square meters per gram is determined from a T1 measurement calculated using the inversion recovery method. This method determines the optimal parameters based on an estimated value of the dispersion T1 relaxation time, the bulk relaxation time, shown here, the specific surface relaxivity, Ka, and the volume ratio of particles to liquid. Up here, the equilibration time is the time in seconds that the software waits until the test starts, after the sample has been installed in the machine. It is meant to allow the sample to reach the same temperature as the inside of the machine. The setting that is best for you depends on the starting temperature of the sample and the temperature inside the machine. If you're not using active temperature control, the instrument operates at a temperature approximately 2 to 3 degrees centigrade higher than the ambient temperature. This time allows the sample to reach the instrument temperature prior to measurement. Up here, the number of scans per experiment is the number of repetitions used to determine the surface area. Increasing the number of scans increases the measurement time, but also increases or improves signal averaging. The bulk relaxation time is the time for the pure liquid to relax, expressed in milliseconds. It can be determined once and saved as a reference value, or it can also be determined individually using the T1 autoparameters method. The anticipated T1 value here is a guess for the dispersion T1. The default value is 1,000 milliseconds. In general, guesses closer than 20% of the actual value are sufficient to obtain good results. The software automatically selects a range of inversion recovery parameters and sets a delay time equal to 5 times the anticipated T1 value. If you're going to select a guess, it's better to guess a larger relaxation time than a smaller one, as the inversion recovery between scans is important to allow the sample to achieve magnetic equilibrium. The specific surface relaxivity is a parameter which depends on the particular particle-liquid combination. We have a Ka calculator, shown up here, which can be used to determine Ka if you have a sample with a known specific surface area based on some other method. The volume ratio of particles to liquid can be accessed from up here where it says particle calculator. In this particular method, you enter in a weight fraction of sample. So for example, 20%, okay? And you click elsewhere, and it calculates the volume ratio of particles to liquid, 0.114, based on the density of the particle and the density of the liquid. So I'm just going to select this, copy it, click OK, then go down here into that figure in this box. Okay. Now that's all you need to do to set up the test parameters. You can enter in the file name here and any important information about the sample in this notes field directly below the sample name. Once you've decided upon a set of parameters that is appropriate for your sample, you can then go and save that method file. So I can call this silica surface area measurement, for example. And later, at this point, the software is asking you whether or not the instrument settings should be saved with this parameter file. Generally speaking, we say no to that. There may be occasions which it might be useful, depending on the particular circumstances of the experiment. So to retrieve those settings, you click on File, then Open Recent Method File, and there is the method that we just created. So you don't have to re-enter these parameters each time, but rather you can recall them automatically for a particular known material and test protocol.